to share with you some basic concepts, I guess, fundamental concepts of Bayesian basics as I've come to understand them. So, data are constantly entering our brains via observations. But observations don't arrive without the influence of prior beliefs. This is the idea of differentiating sensation from perception. As the gorillas put it, you don't see with your eye, you perceive with your mind. Except that you might also see with your eye. A couple of weeks ago, the following observations entered into my brain. Observation number 1. There was no popcorn where I was expecting there to be popcorn. I conjured a memory of having put popcorn on the counter the night before, and yet there it wasn't the next morning. Observation 1, missing popcorn. Observation number 2 was made shortly thereafter when I inquired about the popcorn with my partner, who is the only other human being occupying the apartment and therefore the only person that I could ask about the popcorn. He told me he had no memory of moving the popcorn and asked me if I moved the popcorn. I also had no memory of moving the popcorn. I could not readily think of a time when popcorn had gone missing and there wasn't a simple and quick explanation for its absence, such as, I ate it. Popcorn just didn't go missing around me very often without explanation. This diminished the effect of the observation that the popcorn had gone missing. However, I did have plenty of memories of being forgetful and spacey, and I had no reason to be concerned about popcorn that was already categorized as bird food and would be missing one way or another. These prior beliefs functionally amplified the value of the second observation, which was, I don't remember. And a hypothesis was formed. Hypothesis number 1 was that one of us had forgotten that they'd moved the popcorn. There was a lot of evidence behind that one, and it was loud. Try to think of all of the times you've ever forgotten something. It's pretty easy to come up with instances. Therefore, this evidence, we kind of went with it. So here's how I envision the process by which one arrives at Bayesian statistics. Our observations are whatever data we collect about the world. However, systematically, we collect it. The more systematic the collection process, the more we might trust the data. Kind of works as an amplifier. Or, the stronger we believe in how the world seems to work, the more we might trust the data. Science and faith going after those same neurons. The way observations enter our brain spaces is partly by association. The more information that could be associated with an observation, the more space that observation or idea takes up in our brains. I have experienced no instances that I could think of in which popcorn went missing and there wasn't a simple explanation for it. This idea that popcorn was a worthwhile mystery to solve did not occupy much space in my brain because there just weren't enough or strong enough memories tied to it. The idea that I had forgotten something, however, could easily trigger all sorts of memories of either having forgotten something or being told that I have forgotten something, or having remembered something that I had previously forgotten, thereby acknowledging that I had forgotten it. Simply put, I have a lot of brain space devoted to memories of my having forgotten stuff. The observation that triggers that deluge of memories ends up occupying more brain space than the one that gets a trickle, or nothing at all, such as the mysteriousness of popcorn. The relative weights of these observations, or, if quantified, their likelihoods based on previous experiences, contribute to how much clout the idea gets, which in brainland can be good enough to tip the scales. So the more clout an idea has, the more likely you are to run with it and form a hypothesis about the world using that idea, regardless of where that evidence might have come from. That's why sometimes the loudest voices also seem the most persuasive. In this instance, however, the resulting hypothesis was also fairly easy to support with the data because it combined two separate and likely things, such that if either one of them panned out, then the hypothesis would be supported. So the hypothesis, I forgot a thing, or my partner forgot a thing, combines two fairly likely events and says, if either one of these happens, we're good. If both of them happens, fine. If neither of them happens, that's a problem, but that's the least likely scenario. We tend not to make forked hypotheses like these when engaging in research because it isn't particularly informative to know that one or another hypothesis was supported, but not necessarily which one. But engaging the likelihood of mundane events, it doesn't much matter if your hypothesis is unsatisfying or inactionable. What am I going to do with a hypothesis that either myself or my partner forgot something? I'll probably forget it. A few days later, new observations came in. The night before, there had been a power outage, and a small wedge of cheese that had been left on a stovetop was lost to the darkness and forgotten. Add that to the collection of memories of forgotten things. This new evidence, however, is very compelling, and its signal is being boosted by previous conversations we've had about dealing as humanely as possible with mice, because we unintentionally invited them in, and I don't want to doom them. It is an actionable observation that gets mega points for being a satisfying solution to a mystery and fitting the collection of observations way better than the previous hypothesis, which came from an exaggerated idea that I'm quite spacey and likely to forget things, along with the possibility that my partner, who also can forget things, forgot a thing. A bunch of priors go into these observations as well, such that the cheese with chunks missing from it that were not missing before now just seems to have bite marks. And tiny specks that could plausibly pass for sprinkles arrive in my mind as mouse poops. The hypothesis practically breaks out of my brain by force. It is so obvious. Mouse eats cheese, mouse poops tiny mouse pellets, mouse sometimes lives in kitchens. Hypothesis number 2 sprang forth that there was a mouse in my house and I wanted to do something about it. The idea is that the amplification of observations is quantifiable, and that support for a hypothesis, or how well it lines up with the data, is also quantifiable. What I recreated as the size of arrows altering the impact of the observations can be stated as probabilities and compared numerically. The probability that I had simply forgotten that I had moved popcorn seemed so high that I bet on it being true and moved on with my life. I had a hypothesis and it was good enough at explaining my observations, so I accepted it. This is where Bayesian statistics differs wildly from null hypothesis significance testing. Rather than testing the observations against my hypothesis to determine whether or not I could toss the hypothesis away, I was building the hypothesis on the strength of my observations. And I could toss it away as soon as observations came in that didn't fit it. Rather than supporting or rejecting a hypothesis, you gauge the strength of the evidence supporting one hypothesis against the strength of the evidence supporting another, and you go with whichever one seems better. You can do that mathematically using odds ratios and comparing the odds of one hypothesis being true based on the strength of its evidence against the odds of another hypothesis being true based on the strength of its evidence. It's still a subjective process because you're weighing the evidence with your prior beliefs, which might be different from someone else's prior beliefs. But if enough of us arrive at the same hypotheses about the world, we can put a whole bunch of support behind them and not think twice about whether or not an object will fall if dropped from a height. That's all I've got for at least conceptual Bayesian stats. Hope this was good.